ANZ Meetup, and this is the first Meetup after New Year, after we all have a deserved long break. And today, we are really honored to be joined with two panelists, and it's going to be two separate sections. Yeah, the first panel discussion will be with Nathan Damm from NTT, and will be when he will be sharing his MLOps experience around his industry, which is a contracting firm. Yeah, and Nathan is an advanced analytic practice manager from and in data analytics space, and he is a patented inventor of a machine learning solution. And having worked as a data scientist, consultant, and educator, Nathan has combined deep technical knowledge with thought and people leadership to connect technology with people who need it the most. And Nathan currently heads up the advanced analytic practice for NTT Melbourne Office, where the team focuses on developing user-centric, machine learning-driven data products, utilizing short production cycles and lean methods to get to value for their clients. DevOps and simple deployment are at the heart of their MLOps strategy, and Nathan is excited to discuss this with us today. So yes, welcome, Nathan. Yeah.
Thanks, Augustinus. Pleasure to be here.
Yeah, awesome. So I think I'd like to give you a bit of a minute or two just to elaborate a bit further what you guys really do and what's the machine learning world in your space, really. So yeah, go ahead.
Yeah, sure. Oh, look, I think you've done a fantastic job of introducing me. I don't. Thank you very much for the kind words. I guess a little bit about me before we dive in. I've been a data scientist now for probably going on 10 years. I've had stops at the ATO. I've had stops at Ernst & Young Consulting. Had stops at NBN, where I've been lucky enough to work on some, as you mentioned, some pretty innovative products that we've led to me being a patented inventor of some machine learning solutions, and brief stop at Coles before joining NTT. So at NTT, as you said, we focus on developing user-centric machine learning products that help users to automate and or augment their practices, right? So really keen on using short production cycles to provide value early and get to the heart of the problem and build things that are valuable for both the users and for the businesses that they're working for. Yeah, really keen to kind of dive into what that looks like with you today. I know that you've got some curly questions lined up for me that'll take us under the hood of what that looks like. So at NTT, the practice here has been, we've been on a bit of a journey recently. It's a relatively new practice. We started in January of last year. We were able to grow relatively quickly up to, pretty generous size, and happy with some of the things that we've been able to produce in the last year. We've worked on some cutting-edge natural language processing models, productionizing them in spaces like customer relation management systems, triaging of cases for clients. We've worked in call center analytics, identifying underlying traits within conversations with with customer agents in call centers. And also done some really interesting work in computer vision on satellite imagery. So some really fun stuff that we're working on, but again, always with the user at the heart of what it is that we're aiming to do, and very client-centric also, being consulting practice. So yeah, that's what we do at NTT. I know that you've got some questions about the practice as well, and how we go about what we do. So cool. I won't spill my beans all at once.
Thanks a lot, Nathan. That's a very good elaborate discussion on what you do, and that will help to give the context to the audience. And at the same time as well, I want to let the audience know if you have any question at any time, just drop in your question in the comment section in YouTube, yeah, and we will bring up your question here directly, and I'm gonna ask the question to Nathan, yeah, to answer. So yeah, so fire up your question, yeah. And in the meantime, yeah, so that's, yeah, like I said, that's, we are actually quite excited today because this is the first time actually we're bringing in a guest to share their machine learning MLOps in their organization, which is actually more like a contracting client-centric, which I think from speaking with you like a while back, I noticed there are a few differences. And even though the priorities of what's important, what's not, is actually quite different to if you are running this in the enterprise. Yeah. So yeah, so with that, I have a few questions here. The first one is, just to first to give you everyone more context, yeah, for the next few discussion. I'd like to probe a little bit about your organization and especially your team. Yeah? And what is your team structure and what are the responsibility of each? So this hopefully will give an idea like why you choose to have this type of MLOps platform. Yeah.
Yeah, for sure. Yeah, so look, I mean, at its heart, NTT is a technology professional services company, right? So we partner with our clients and to consult them on how to, I guess, best do their advanced analytics projects. And that can involve partnering with them from any point on the I guess maturity curve. So, you know, customers who maybe don't even have a data platform in place as yet, all the way through to wanting to do descriptive and then predictive and prescriptive analytics. We, you know, within the domain, so I run the advanced analytics practice. Within the domain, we also manage things all the way from data governance. We do data platforms, engineering, you know, reporting and visualization, and then the advanced analytics, machine learning, and data science. So really kind of can, you know, the technology, the cloud technology stack to be able to go all the way from data offline in Excel spreadsheets all the way up to having quite a mature, I guess, machine learning platform and deployment. So we, you know, as you said, you know, we're a consulting company, so we're not incumbent within the organization. Hopefully you know, we want to partner with our clients to identify what's important to them, to align to that. But I think having a platform that can really manage the entirety of the maturity curve is really important to us, right? Because we want to have some reproducibility. We want to be able to really quickly kind of move into our client space and be able to provide value early. I think that's a really, you know, as we talk, you'll see that, you know, we consider that at NTT to be really central to making these things effective, is showing the client that the investment is worth it, and that they can see the you know, the return on investment that they're getting. A big part of how we do that within my practice is the competency structure. We have a real focus on, as you've kind of touched on, like lean product development. So we really kind of focus on, you know, 3 core facets of making products valuable. That is feasibility, which is, can we do it? Do we have the technology available? Viability, which is, can we afford it? Is it going to be cost effective? And desirability, which is one that gets forgotten quite a lot. Does anyone want to use the thing that we're building? And so look, our practice, I you know, I have, you know, myself leading the practice, and I have multiple competency leads within that practice. Those competency leads tend to be, like, well, not tend to be, they are more, you know, I prefer a flat structure. You know, we're all of the data scientists and machine learning engineers that we have are very switched on in their own right. We don't want to have some big pyramid scheme going on. It's more about us having an effective leadership strategy and an ability to ideate and share those ideas across the practice. So those competencies aren't necessarily verticals, but they're horizontals. So the competency leads drive out and the competency, the concept to the rest of the group. Those three competencies line up really closely with desirability, feasibility, and viability. To address desirability, we want to be really good consultants, right? So data science consultancy is central to what we do. For feasibility, we want to be on top of the technology. Obviously data science is a fast-moving space. We want to make sure that we're up with the latest and greatest, ready to deploy technologies that are available. So we have an applied research competency. And then the one that we'll focus on more today is our viability. And to address the viability, I think you need to have the right platform in place. So we have an MLOps competency to drive out platform and delivery.
Okay, so in terms of skill set, right? It's the data scientist, a mix of data scientist and an ML engineer. And what about your applied science? Is it also a data scientist? Or?
Yeah, so I would say that. So I mean, the applied scientists, applied scientists are probably the smaller group within the practice, and as they're data scientists, but they're much more interested in the what and knowing, being on the cutting edge and driving out things like knowing how to apply BERT language models and knowing what the best object detection scores for particular model types are going to be. So then again, that we can go into a client and be really dynamic in how we're driving out a solution. The other our data scientists who are in that kind of consulting competency, again, data scientists, but focusing a lot more on that delivery and client outcomes focus, which I think is really important, because I mean that partnering with your clients, and we could do a whole half-hour discussion just on how to do that best, or how we feel like it's best to be done, is central to ensuring that products get off the line. And then for the ML engineers, again, it's about making sure that we've got a platform in place that allows us to move really quickly from an explore environment where we're experimenting and trying different methods, and getting that, when you find something that works, transitioning that into an exploit environment where you've productionized and deployed. That's so central to making it work, right? Like, I mean, the last thing you want is to be developing something and to have all the stakeholders on board and build something that has demonstrable value. You've done it iteratively, so then you've not just been locked in a black room, a dark room, and developed something that no one actually wants. You've got something, everyone's on board, they want it, they want to develop it and deploy it, and it takes 3 months in a black backlog before you can get it into production. That's just a very fast way to make sure that all of that hard work that you've done in getting the stakeholders on board, they forget about it before it even hits production.
Yeah. So I saw a question from Andrew Gillespie, but I will hold off that question until you answer the second question around your MLOps platform. So hopefully that will give more context to that question. So I'll come back to your question, Andrew. Yeah. So the second question, like I mentioned earlier, we keen to know what is the MLOps platform that you guys use? Can you share what's good and bad about it? What works, what doesn't? Yeah. Especially in your consulting firm. Yep.
Again, there's probably something that you and I could and have before talked at length about. So I'll try to keep the answer relatively pithy. Look, as we were talking about in terms of that MLOps platform, wanting to move things really quickly and easily from explore to exploit, there are some things that we really want from our ML production or ML development platform. We want it to be light, right? We want it to relatively lightweight. We want to be able to move from, be dynamic to our customers' environment. So we want it to be available on multiple clouds. So you need to be able to do it in Azure, you need to be able to do it in AWS, and you need to be able to do it in GCP. Predominantly, there's going to be other clients who have other bespoke things, but those are the main three. I think you want a single platform. There's nothing worse than coming into a client and trying to land 2 to 3 different platforms for doing a singular task. And as I've said, moving from explore to exploit, you want to be able to experiment, but also deploy on that singular platform. For us, what that looked like when we went on a bit of a discovery journey as to what we wanted that platform to be, we settled on Databricks because we felt like that met so many of the needs, being that it's lightweight, agile, single platform for engineering, data science exploration and deployment, and that you could really quickly and easily deploy things. It's also native to those different cloud environments and really fit the needs of quite a lot of our customers. I think when you look across the industry in Australia, we aren't at that point where most businesses or industries have 10 machine learning models in production or 20 machine learning models in production. Those companies definitely exist in Australia, but they're not the majority. And so quite a lot of our customers come in, they need a lightweight platform to start off to again prove the value early. Look, we love it. Like I said, it's cloud agnostic. We can, it has Spark as native, so you can do your data engineering. You can get the data in, you can cut the data up, which is an absolutely integral part of the machine learning pipeline. I think something that you were really excited about when we were talking about it, Augustinus, is central to what we do is being able to port things between different clients. Now, quite often, I think that data science is innovation. We're building new things for our clients, and it's always exploratory. You never start building a machine learning model with great confidence that you're definitely going to get the outcome. So we're always fine-tuning things, but we want to be able to be relatively portable. So using MLflow is native to Databricks, and there's so many functions within MLflow that are so helpful to doing just that. Central of which being the project structure. So you can package up a project in Databricks. So you package it up and produce a singular object for moving that project between Databricks environments. So you can have reproducible runs on any platform, combines with Git for source control and dependency tracking and all of those things that can really throw a curveball to a model in production. It makes that portability really easy. Other things that are really helpful coming from MLflows, the model registry. It allows you to have a centralized store for all of your models, makes it handy for tracking and API deployment. Also, another facet of Databricks that we really love is the Databricks jobs. So you've just gone through that explore process. You have a notebook that works. You can one-click deploy that. Now, that's really helpful if you want to pilot something. You can also put quite a lot of, you can build your MLOps function and your methodology around that as a function and say, look, obviously you need to have quite a few bells and whistles if you want to have that to be a hardened production pattern, but it does allow, if you have the checks and balances in place, it does allow you to have single click deployment, which is, if you're wanting to have that kind of dynamic, really easy step from explore to exploit, I think is really central. I think you asked about some of the things that we don't like about it. I think, look, I mean, Databricks is great, and I think it really provides a lot of what we're looking for. Things that it struggles with is, model monitor. Well, not struggles with, but in terms of model monitoring at deploy time. So if you're wanting to monitor the performance in production, that's something that you still have to. No, MLflow doesn't manage that out of the box. You do have to kind of write that in explicitly as part of your production job runs, and there's no native dashboards or anything for monitoring. You have to build those bespoke. Can be done. It's not difficult, but I mean and I'm sure that that's a feature that's coming for Databricks in future. The Git integration also in Databricks is a bit janky. There's you can't really fork a project or anything like that. It's very simple Git integration, mostly tied to the fact that it's all notebook centric as opposed to Python file centric, which is another, I guess, it's a restriction of the platform, but one that I think we prefer the agility that it has.
Cool.
Custom containers can be tough. So, if you want to containerize things and port containers between environments and things like that, it's a bit of a challenge in Databricks. And then finally, something that's really important to the client is if you're wanting a platform that's a one-stop shop, it is code first, right? So there's no, if you're wanting to have, non-developer or non-coding people engaged in the platform and being able to query your data, then Databricks doesn't really have that in terms of GUI support and things like that.
Cool.
I think a big thing is that, I think Databricks is awesome for that first platform all the way through to being quite mature. Other platforms out there like DataRobot, DataIQ, I think they're awesome, but also not the thing that you do to build your first through 10th machine learning model and productionize it, right? They're the kind of things that if you've got quite a mature, machine learning development and productionization function, I think those platforms provide a platform for doing that.
Yeah, so cool. That's awesome. That's a lot of information. I believe it's very useful for the audience. Yeah, and let me now bring up a question from the floor. So back to the first question. Andrew asked, how do you evolve your R&D tech research to say delivery and MLOps teams?
How do we feed it through? Like how does that R&D get to the delivery team?
Yes. How do you evolve your ML R&D tech research? I think it's if I try to understand this question correctly, from your.
I think I understand.
Okay. Yep, go ahead.
Yeah. I think I understand it. I think kind of how I hope. Sorry, Andrew, if I haven't summarized it correctly. Obviously, this platform doesn't allow me to confirm my understanding of But look. We have regular meetups. Those competency leads, that's their responsibility as leaders within the practice to drive out their thought leadership. You've got that ML and R&D research. We do quite a lot of for any internal POCs. We always do showcasing of work and whatnot. We also have a regular reading group, which I think if you've got a team of data scientists, please dedicate time in their week to or month or whatever time frame works for you to learning, right? And allowing them to share that learning. I hope that it's really just about having those that regular cadence. So the reading groups, we've got our head of the lead machine learning engineer has regular meetups with the guys around driving out how we want the platform to work and upskilling. And so, I guess we dedicate a lot of the internal time to training, because I mean, that's what makes those guys valuable to the clients when they get there. Cool.
Awesome. Thanks, Nathan. So the next question is from Nick, and I'll bring up the question here. Does Databricks cater for
absolutely.
Model?
Yeah, so Databricks at its core is a Python notebook environment, right? So there's a whole heap of native Spark things that you can only do, that you can only access through Databricks, because I mean, anyone who knows the history of Databricks knows that it was developed by the team that developed Spark, and so the latest and greatest in Spark is available on Databricks. So you're accessing all of that through the PySpark API, but everything from there downstream is Python. Like, it is Python code. So it's all either open source or whatever packages you've developed internally, you're coding in Python. So we've got, I know some of the guys within our team like TensorFlow. I try to get them to use Torch as much as possible because I think it's better to deploy using Torch. And again, we could probably have an entire chat debating that alone. But yeah, sklearn is our bread and butter. Yeah.
Yeah. Well, and also because the Databricks uses Metaflow, right? Yeah. Sorry, MLflow. So MLflow have like a support for each of those framework natively.
And yeah, look, I mean, I know that, and I may jump in there because I'm mindful of time, and I know you wanted to talk about MLflow a little bit about experiment tracking, right? And look, that's so central again to, if you're going to be constantly exploring, you want to be able to find something that works and then deploy it as quickly as possible. And MLflow again has that experiment tracking that makes that so easy, and it works straight out of the box. Before us committing to picking up Databricks as a platform, I hadn't used MLflow a lot. I knew that it was out there. I knew, I guess, the capabilities, but I hadn't used it myself. And I was really impressed with the how much works just straight out of the box, just with a simple API wrapper. You go like start experiment, stop experiment, and all of your code in the middle. And just how much straight out of the box MLflow will grab from those different, say, an sklearn model or a TensorFlow model or a PyTorch model. It just grabs that stuff pretty easily. If it doesn't work, so I mean, we use FastAI a lot for deep learning development. There are kind of, you can download a package to make MLflow play nicer with FastAI, and again, then it just automatically pulls a whole heap of, say, your accuracy metrics and your hyperparameters and your data that you're seeding the model with, the code, it packages up so then you can go back to a particular experiment, see how it performed, and reproduce it. And I think reproducibility is really key to being able to deploy quickly, because again, you want to be able to, look, I think we talked about this, Augustinus, it's a journey, right? It's that education journey, does every data scientist record their experiments as, with the veracity that they should? Probably not. But it is an absolute pain when you get a fantastic result and then you come back the next day and your environment's reset, and for whatever reason you haven't saved your notebook, and now you don't have those hyperparameters, or you don't have how, the feature engineering that led to the fantastic result. And look, I mean, and this is I approach machine learning more like an engineer than a statistician, and sometimes statisticians get a bit frustrated with that, but there's nothing you cannot deny that the training data that you use can vastly change the performance of a model, right? And being able to capture that and know exactly which training data you fed to which model to get which result, and again, having the MLflow model registry, so that model is just sitting there saved as an artifact that you can just go, oh, everything's reset, but we can go back to the experiment, we can see the performance, we know which model it is that it trained, and we can load that back into memory, and we know what the feature engineering was because we have the code available, is a very powerful tool. So
cool. Thanks a lot for the detailed explanation on the experiment tracking. Yeah? And yeah, I couldn't agree more than what you said, Nathan. So I think that's the end of our first panel discussion. And thanks so much, Nathan, for joining us. And totally, I learned a lot today from what you said, and I believe audience will feel the same. So thanks for coming in. And for the audience, stay tuned. We will be moving on to the second panel discussion. Yeah. So see you, Nathan.
Thanks so much, Augustinus. Thanks, everyone.
So welcome, Julian. Wow, you look a lot taller than me. let me come closer.
Maybe I need to move back from the camera a little bit.
No, that's okay. You're fine. So wow, welcome to the second panel discussion. And Julian Bright today is going to discuss slightly different topics, still under MLOps, but it's going to be touching a little bit more like a experimental development of the model as well, right? And Julian Bright is actually a founding principal engineer from Predibase, and Predibase is a startup which built a declarative deep learning platform that provides a glass box interface to create a state-of-the-art model using a simple SQL interface. And Julian is a founding engineer with Predibase, where he works remotely from Melbourne. And I also learned recently you are currently in Bright, yeah? Oh, sorry, not Bright, in Rope, yeah? And he to build the next generation machine learning ops platform for data professionals. And he has over 20 years of experience architecting and building software at companies including Amazon, Microsoft, and SIG. So that's quite a journey, Julian, and welcome on board today. Yeah, and
thanks for having me, Gus.
Yes, always a pleasure. And Julian, just like the first panel discussion, I'd like to give you like a 1 minute just to elaborate a bit more what you do and you know all this. What is this a very interesting startup that you guys been working on, and finally you reveal the curtain today. So yeah, go ahead.
Yeah, thanks, Gus. So about 6 months ago, I joined Predibase as a founding principal engineer, and essentially what that means is I'm helping to build the technology stack for machine learning that Predibase is still actually in stealth mode. So this is the first sort of public talk we've had about it, but we will be launching very soon, actually later this year, and we're going to be opening up the platform to initially sort of private beta testing, and then hopefully later to the rest of the world. So prior to that, I was at Amazon for many years. I spent quite a few years working directly with customers on building machine learning ops solutions. So published a number of blogs and frameworks, and really, was sort of helping customers on that journey to make sure models didn't end up languishing, but made it into production, and putting sort of orchestration and frameworks and repeatability around that process. And so the reason I joined Predibase is really just to sort of, get back on the tools and also help building what I think could be the next generation for machine learning. It's a very different, actually, a way of thinking about building models. I've got a few slides to maybe talk you through some of those concepts today, because it is a little bit new, but I'm excited to be here.
Cool, thanks, Julian. Very keen to drill you guys down more details on this. So let me start with the first question. But before that, let me remind the audience again, if you guys have any question at any time, just drop in your question in the YouTube comment, and I'll bring it up here for Julian to answer. So first question. I hear a lot of discussion about AutoML and low-code machine learning platform. What do you think as an industry, why we are seeing these trends?
Right. Sure. Let me. I'm just going to share my screen. Actually, I've got a couple of slides here, and I'll just switch into those and talk you through maybe a few of those points. So hopefully you can see my screen now.
Yep, it's on now.
Great. So I guess from my experience, what I've seen is the entry point into machine learning these days is often, one of two ways. AutoML and low-code platforms have come a long way since the last few years, and it's sort of kind of be a default option for a lot of new teams starting out, maybe that don't have that deep technical experience. But really, you have sort of two clear choices at the moment. You have the ability to go and build machine learning models using those low-level APIs, and often that'll be done in a notebook using a framework like scikit-learn, or maybe PyTorch if you're building a deep learning model or TensorFlow. But you still need to do quite a lot of heavy lifting there. So, the data engineering, the feature engineering, all those elements prior to getting the model built and trained can be quite, a laborious process. And we see this because models take many months often to get into production through using these frameworks and tools. You do have that power, you do have that flexibility, but there's a challenge often getting into production, which is why I focused heavily on that when I was at Amazon. On the other hand, AutoML tools are great for getting that first model trained, but there are a couple of downsides that we see with AutoML as well. Number one, they often are a black box. So what that means is effectively you don't really get to tinker with the black box too much outside of telling machine to try and change the data set, etc. They'll often have hyperparameter sort of optimization, which is basically a fancy way of saying twiddling a lot of different knobs to try and get the best performance for the model. And then I guess once you've got that model, because they often have been trained with these very sort of sophisticated and complex processes, it's often hard to repeat that in a cost-effective way, because you're often having to repeat that whole trading process. And so whilst there's these two options right now, and we're seeing a lot of new teams start with AutoML, they often graduate off that platform once the data science sort of folks get on the tools and say, look, we're sort of limited in what we can do here. We need to be able to have a little bit more control. And that's where you often have people sort of revert back to these low-level APIs. So I guess in terms of Predibase and declarative machine learning, it's kind of trying to find that middle ground, if you like, between the two systems, where you can actually have more of a sort of glass box approach, and you can control some of these parameters that the AutoML tools sort of take care of for you. Does that make sense?
Cool. Yes. Wow. So it's like the best of both worlds. Yeah. Being able to control, but also not
That's
to.
the idea.
Awesome.
Yeah.
Awesome.
Yeah.
So let me bring up the next question. Okay. So could you please share a little bit with the audience, what is this declarative deep learning platform, and what problem that actually you are trying to address? Yeah.
Right. So I guess with declarative deep learning, as you can sort of see there, we're positioning it as a sort of middle ground. But if we talk about Ludwig, which is actually the open source framework on which Predibase is built, this was one of the earliest implementations of a declarative deep learning solution. So Piero, the founder, open sourced this piece of software whilst at Uber, alongside of Travis, who's also a founding member of the team. And another founding member is also a professor from Stanford who worked on something very similar at Apple, Christopher Ray. He built a product called Overton. And basically, these two ideas take the concept of defining the model in saying what you want to do. So really what you do is say, hey, I've got these input features and I've got an output feature or a target. So it might be, for example, you're predicting fraud. So you've got a bunch of input features and then you've got an output being fraud or not fraud, right? So that's a simple model. But you can imagine as this gets more complicated, you've got different sorts of models that you want to implement. So for example, maybe image captioning has an input, which is an image, and then the output will be multiple sort of sequence of words. And in fact, you can have models that have multiple target outputs as well. And so Ludwig allows you to basically express this in a very simple way using YAML in the open source tool, which basically says what the inputs and outputs are, and then how you sort of configure the model. And this includes things like what pre-processing to apply, how to encode certain fields, what sort of parameters you want to use for training, and also has an easy way to sort of serve this. And so this tool was the genesis of Predibase, and in fact, we're contributing heavily back to this open source product, which is being upgraded to actually now target PyTorch, where the first version originally was a TensorFlow backend. So this is kind of the genesis of Ludwig, and I guess the future is how we're integrating this into Predibase.
So as a client, as a customer, as a user to this framework, you do not get to choose what is the framework behind the scene, whether it's TensorFlow or PyTorch or anything else, yeah?
Well, no. So this is all built on PyTorch. So we made the decision to port the core engine from TensorFlow to PyTorch based on a couple of factors. Number one, the community was really sort of getting behind PyTorch in terms of things like Hugging Face and other frameworks were building quite sophisticated architectures for NLP, as well as a lot of the image processing pre-trained models are now starting to really leverage a lot of the PyTorch infrastructure. Plus, there's a great community there, and also some really nice features with PyTorch insofar as it is a dynamic language by default. TensorFlow's now adopted a similar approach, but being dynamic, it means it's very flexible. And there's also some great features in PyTorch, such as the ability to compile to TorchScript, which is a very efficient way of serving as well. So there's a lot of great kind of things that are built into the PyTorch ecosystem. And, we sort of realized that this was going to be, where a lot of the innovation was happening in the future. So that's why, we sort of leverage that. Having said that, you can build your own custom encoders and features on top of the framework itself. So you're not limited to, kind of what's out of the box. You can actually extend it to meet your own requirements as well.
Wow, sounds very powerful. So if you want to extend it, you can actually build your own encoder, things like that, and yeah.
Correct. Yeah.
And even like a maybe, I don't know, like a plugin, a different type of encoder for audio, things like that, or natively supported?
Actually, we do already support audio as an input type. Audio, video, images, they're all supported. Yeah.
Wow. Ooh. So it's what AGI is coming your way.
Well, I think as you'll see, you know, having that flexibility gives you a lot of options, particularly as we look at multimodal models, which has become another hot topic this year, which is essentially, you know, where you have different types of unstructured and structured data combined together into a single model, and being able to do that in a concise way is really quite powerful with a framework like this.
Cool. Awesome. Wow, this is very interesting, Julian. And the next question I'd like to ask is, you already show a little bit about how it really works, but will be good if you can actually show us what does it look like to use your platform from end to end, like starting with building the model,
Sure.
and ends with like deploying it. Yeah.
Okay. Yeah. So let me give you a little bit more context with respect to Predibase and how it extends the platform first initially. So one thing we've done with Predibase is we've taken that core of Ludwig, which is the declarative deep learning framework, and then we've extended it into one way is we've added a simple universal interface, which is a SQL-like language that you can actually run to query, create models, and do all sorts of things within the platform. So it makes it a lot more accessible to data analysts and people like that who are very familiar with SQL. And then we've taken, you know, a great tech, which some of you may have heard called Ray, which is a distributed, you know, sort of framework that is general purpose, but really allows us to focus on building out a really scalable, reliable backend system. So we have this concept of engines in Predibase, and those engines are then able to run distributed training jobs effectively at scale using our software as a service platform. So I'll get into a demo in a minute, but I just wanted to sort of highlight some of the key features and the reason this is a SaaS platform and sort of on top of that core open source runtime. So we allow users to connect data, be it structured data from a data warehouse or unstructured data from something like a blob store, and we support, you know, all the different clouds, Amazon, Google, Azure, and then our platform itself can, you know, provide that query interface and supports deployment options both for batch inference as well as online inference, as we'll see. And there's an SDK that kind of allows you to use this for a notebook or some other environment if you're still wanting to build out some experiments and sort of code based outside of the actual platform itself. Okay, so you're probably wanting to see a demo. Let's have a look if we can get that happening today. Right, so hopefully you can see my screen here, which is the interface for Predibase. And so what you can see is there's sort of three use cases around the platform. One of them is connecting data. So that is a case of, you know, firing up one of these connections here. So as you can see, we support a number of different connections. Once you connect the data sets here, you can see them uploaded, and then you can obviously query them. There's a model building piece here that sits on top of what is that core Ludwig runtime, but I'll come back to that in a minute before I just show you basically what we've got here in terms of the SQL interface. So if I pick my connection here, I can see all the data sets that I've got available, and then I can run something simple like this query. So in this case, what we're doing is we're getting back some results from the Twitterbot data set. Now, this is an interesting data set because it is multimodal. And so by that, what we mean is we've got different types of data sets. So for example, we've got some description data here. We've got some, you know, categorical numerical values here. So follower counts, things like that. And we also have image data as well. So things like profile photos, etc. And so what we're able to do is in this instance, we're looking to predict whether or not this particular record is a bot or not a bot. And so we can extend our sort of syntax here and run a query like this. And so what this is now doing is it's extending the SQL language to make predictions against whether or not this is likely to be a bot or not bot. And so you can see we've got the new column here, predictions appearing, and then we've got that prediction right here. So very simple. And not only that, you can extend it with other features. For example, I can say with explanation or with confidence, for example. So with confidence will give me the probability back as to how confident that particular result is. And so I'll get those results back and I'll be able to see those here with another column that relates to that probability. And we've also integrated explanations as well. So this takes a little longer to run, but effectively what this performs is a SHAP sort of analysis on the back end. And for those who don't know, that's a sort of visualization of, well, it can basically be visualized to show how effective this is. Now, let me just have a quick look to say, pull up a previous result set so I can explain how that works. So that's still running in the background here, but I can look at a previous result set. And what you can see is that overall, if we look at this predictive model, we can see that the unstructured fields such as description is actually really predictive in this case overall. Follower counts, language, and other elements are also predictive. And then if we want to look at individual recommendations of sort of based on that SHAP analysis, we can also do that here. And we can see, the status count in this particular case was the highest sort of probability predictor, and then other parameters down here. So that's one example of how we can use that SQL-like language to do predictions. But the thing I was talking about earlier in terms of that glass box, and this is where we talk back to the Ludwig model, is if I wanted to create, so the Twitter bot example here, and this is where we pick our sort of compute engine size here. I'll take the Twitter bot data set, and then what I can do is, I'll come back to this visual in a minute, but I can look at what features are in that data set. So I might want to enable the description, for example, because I know, that even though it's still missing some values here, it was quite predictive. And if I go back to this overview here, we can actually see this is the visualization of the sort of internal representation of the model encoder and decoder. So you can see here we got a description, it's a text type, and it's got a particular encoder configured. So we can go and change that encoder to be something like a BERT model, a RoBERTa, etc. And we're pulling in essentially Hugging Face, state-of-the-art encoders here. And we can, of course, bring our own or customize this as well. And so in addition to that, you've got a whole bunch of features here. And this is what we talk about when we say glass box. So it's like, what's embedding size, how many filters are we using, et cetera, et cetera. And you can do this for all the different types of features. So that's text features, categorical features, numerical features, images, et cetera. And of course, in addition, we do support hyperop and the ability to run that hyper optimization, which we'll do that sort of classic AutoML sort of intelligent search across the different parameters. So yeah, that's a little bit about the platform and the demo. Hopefully that was interesting to folks out there.
Well, definitely interesting for me, Julian. And it's cool, like everything can be just drag and drop and no need to worry about like forgotten the syntax, how to do this in TensorFlow or PyTorch, and how to specify the CNN parameters in the layers, things like that, right? And and it was so powerful. I can see like you actually basically tell the system I want to make a predictive model, but I don't know how do you actually tell the platform that you want like a regression or classification. I can just like I only can see in your query like predict something, but how do you just
right?
Yeah.
So when you set up that model in the first instance, you specify what the target features are. So for the Twitterbot model, the target feature was a single feature, which was account type. And so once you register that model as responding to that account type, when you make queries for that account type, it knows to go and use that model for that particular data set. So we have things in the language, you can say using a specific model or a specific version, or you can customize how the system picks up the particular trained model. But yeah, you can use one or more target features, and the system is configured for a default model against those target features.
I see. So if it is a number, then it is regression, obviously, right?
Right, yeah. Right. So typically, there's obviously classification, regression, but then there's other sort of models like, as I said, sequence prediction for image classification of describing what's in an image. So that's a different sort of model. So yeah, you basically define in the configuration what the type is. If it's a numerical value, then it's a regression. If it's a categorical value, it's a sort of classification in that sense.
Yeah. Wow, that's the first time I've seen this. Yeah, I've seen Ludwig before, but yeah, like you bring a nice UI on top of it. And also not just that, you also now adding all of these other the component that you can plug into this declarative model, right? That's super awesome. And right. I also like you mentioned that you have a Python SDK. I'm not really a big fan of Jupyter Notebook, so Python SDK is like awesome. Yeah. Yeah. So you can.
Yeah. So the Python SDK will allow you to create those connections, data sets, or models, and you can do that just through code. And so that'll, basically do the same thing as what you would do through the UI. And in fact, I didn't really show this, but the language syntax around PQL supports all these extensions as well. So you can type create model, and you can do similar to a create table. You go ahead and create model with a series of parameters, specify the target. You can even specify the encoding, decoding in a SQL-like syntax. And so we kind of have this principle that whatever you can do in the UI, you should be able to do through both the PQL language as well as the Python SDK.
I see. Yeah. So we have a question here from Trish, and I'll bring it up. So Trish asks, how does Predibase compare with platform like Alteryx for MLOps?
Right. Yeah. So I guess Predibase is more of a flexible platform, given it's based on open source technologies, and it certainly has some MLOps capabilities. So things that we take care of, for example, are automating the training process, including that distributed training for you. We also provide batch prediction through the platform, and coming soon we'll provide real-time predictions as well through REST APIs, which you'll be able to sort of scale out based on your volume and load that you can expect. In terms of integration with MLOps tooling, we do actually support things like integration with experiment tracking tools for capturing metrics, although we also have those visible within the platform. And we're working on integrations with a company called Ylog for monitoring, for example. So we're looking to sort of integrate the best of breed tooling. For example, on the sort of data ingestion side, we're working with the folks from DBT to leverage sort of some reverse ETL capabilities that tool provides within the data warehouse, so we can sort of have the data preparation happen through those platforms, and we don't need to sort of own that whole end-to-end pipeline. What we do focus on is a really flexible way of building high quality models, and then also being able to provide that flexible interface for data analysts and other data folks.
Cool. So I have another question. Like this is around deployment, right? You already show like this is actually an SaaS platform. So I believe at the end of the process, I can deploy the model into, say, like I want a real-time API, right? So I can deploy within the SaaS, and you will be given a URL you can actually call, right? Is that how it works?
So that feature will be coming soon. Currently, as soon as the model's trained, it's deployed within our infrastructure for batch prediction through the queries. And in fact, one thing I didn't show, but we actually support what's called a what-if analysis, which is actually a way to provide predictions not against a data set, but against some regular inputs, similar to what you would do for a classic REST API. I can actually just show you that quickly if you want to have a look at that. It's a pretty neat feature of the platform. So I'll just pop back into the browser here, and I think it might be this one. There's a history here. I think it might be this one. Yeah. So instead of predicting against a SQL select statement, I can predict against a given series of inputs here. And so not only do we support static inputs like these, in this case, we support enumerating various values, we support joining that with other data sets. And so you can do this sort of exploratory hypothetical queries that we call them, where you can say, okay, I've got some data, and then I want to mix that with some other other values that I might not be seeing in my data, and then I want to see what the predictions look like against that. So it's a really sort of new and novel way for analysts to sort of experiment with what happens if I change different data sets. So you could actually provide this through the Python SDK and obviously get a prediction back on specific inputs, but you can also do it as part of an experiment and analysis sort of for different types of data, looking at things like bias and that sort of stuff within your corpus as well.
Wow, that's awesome. Yeah, it's definitely look very different to the normal world that we're living in currently. When creating REST API, or if it is SageMaker, you use the SDK, but it's like you just simply writing a query to execute your inference.
Yeah. So we definitely will support REST APIs. And in fact, one of the nice things, as I mentioned about PyTorch, is it does support the ability to compile models down to TorchScript. And so we've actually built infrastructure within our open source solution to also compile down the pre-processing and post-processing steps as well. So that's one of the things that AutoML tools often do for you, but it's usually run sort of prior to the actual inference itself. And then you need to figure out a way of repeating that process when you actually make the inference. So we actually provide a model ready for serving that has all the pre-processing and post-processing already built into that endpoint. And so we can, because that's all torch script, we can just host that with any regular API. In fact, the one we're looking at is the NVIDIA Triton framework, because that's a really sort of flexible, powerful, low latency runtime as well.
Sure. So another question that I'd like to ask you is like, in MLOps world, you do not just build the model once. Yeah. So very often that you need to continuously build the model with the new data, right? So I don't know, daily, weekly. So how does your MLOps platform handle this?
Right. So again, there's another feature I didn't show you in the platform, but there's the ability to set up scheduled queries. So you can basically say, I want to run this particular query every week, say, and it'll make those predictions on, say, new data. And we can also do things like set up a scheduled query to do a retraining exercise. So again, that's just some SQL syntax. The schedule just says, what do you want to run? And it might be, I want to retrain the model, or I want to insert data into some table, or I want to create table as some prediction query. And so we kind of like make it really flexible and allow folks to run up, these regular retraining schedules or whatever it is, just using that process. But we're also, thinking about how to integrate more closely with YLabs, as I mentioned, for automation of retraining. So we'll be able to know when models drifting, for example, and then we'll sort of be able to re-trigger the retraining pipeline.
Sure, and because you guys provide Python SDK, basically we can use any platform and just they actually can run a scheduled task, and you just call your SDK to execute that training, right?
That's possible as well. Absolutely, yeah.
Yeah, cool. Wow, awesome. So this is definitely something that interesting for me today to see. Yeah, so thanks a lot for bringing this up, and I believe all the audience will also share the same feeling. So yeah, so with that, I'd like to close this panel discussion. Thanks a lot, Julian, for coming in today, and we'll begin to see the next iteration of your platform. Yeah.
Excellent. Thanks for having me, guys.
All right. See ya. And with that, that's the end of this MLOps ANZ today. So thanks everyone for tuning in, and yeah, so this is like a community event. So we're giving back to the community as opposed to we also watching from the community presenting. So if any of you audience have something that you would like to share and you think it will be useful for others, please reach out to me. Yeah, and just and we can schedule you to be the next speaker. Yeah, we can actually share your knowledge to the rest of the community. So yeah, thanks a lot today. So hopefully you all have a very nice Easter break and stay safe. See ya.